on your screens now. So this says a number when divided by 361, right? A number when divided by 361 gives a remainder 47. If the same number is divided by 19, the remainder obtained is. Now this is a very popular question type from number theory or number systems, and I'm sure you know the smart way to solve this question as well. However, I'll give you about 30 to 45 seconds to try this, and your clock has started ticking now. 9 is the answer, right? Glad to see that many of you have marked the answer already. Good. So I think time is up. Most of you have got, in fact, all of you have got option C as answer, which is 9. Let's discuss the solution now. Okay, here we go. So the question here is a number when divided by 361 gives a remainder 47. If the same number is divided by 19, the remainder obtained is. Right? So let's understand the process here. He says there's a number, and that number when divided by 361 results in a remainder of 41. It gives you a remainder of 41. Now how do you frame an equation on this statement? So it's all about converting this statement into a mathematical equation so that it's easy to deal with it, right? So there is a number which when you divide by 361 gives a remainder of 47. Let's assume this number is n, right? The number that we're referring to here is n. So n when divided by 361. Now how do you divide n by 361? 361 here, right? It gives you a remainder of 47. 47 is the remainder. So of course you'll obtain some quotient q here, right? Now I can say that the number n here is equal to 361 times the quotient plus 47. That's the understanding, right? Divisor into dividend, sorry, the divisor into the quotient plus remainder gives you the dividend, the number, right? If you understand the terminology. So the number n here is nothing but 361 times the quotient that you get here, right? See, divisor when multiplied by quotient will actually give you the number when the remainder is 0. If there is a remainder, you add it up. So that is the remainder here, 47. So the number n is equal to 361q plus 47, right? 361q plus 47. Now he says the same number. What do you mean by the same number? The same number n. This number n when divided by 19, what will be the remainder? So this time you have to divide n by 19. So let's divide n by 19. What happens? What do we get? We'll get 361q plus 47 divided by 19. Now this actually can be split as 361q by 19 plus 47 by 19, right? Understand the first term here, 361q divided by 19. Whatever be the value of q, I can conclude that this number is divisible by 19. Because 361 is a multiple of 19, right? 361 I guess goes 19 times, right? 19 squared. So I know that the first term is divisible by 19. So no worry of remainder. Here the remainder is going to be 0, right? From the first part, the remainder is going to be 0. It will be 0. The only thing you have to check is what is the remainder in the second part. What is the second part? 47 divided by 19. Now when you divide 47 by 19, what is the remainder you get? When you divide 47 by 19, the remainder will be 9, because 38 is divisible by 19, right? Again the same process. It will help you understand how to frame the equation. 47 is being divided by 19. So I can say 19 2 times is 38. Whatever is left out is 9. So try and compare. What do we say? 47 actually is equal to this divisor 19 multiplied by the quotient 2 plus the remainder 9. Yes or no? I mean, just to give you an analogy, you can compare these two. 47 is the number here, n. 19 is the divisor, like 361 in this case. 2 is the quotient, 19 into 2, 38 plus 9. Right? Anyway, the point is when you divide 47 by 19, the remainder is 9. So when I divide the overall number also by 19, the remainder that I'm going to obtain is only 9, because first term is divisible by 19. So answer here should be option C. Now do you have to do all this in the exam? Not really. All that is required in the exam is simple. If you have solved 1 or 2 such questions, you would know the idea. See, he says the number when divided by 361 gives you some remainder. Now same number is divided by some other divisor now. So what is the remainder? Yeah, all you have to do is take the remainder 47 and divide that remainder by the divisor, the new divisor. Whatever is the answer, whatever is the remainder you get there will be the answer. So simple. Instead of doing all this, I mean, this is definitely required for you to understand the process, but simple technique is divide 47 by 19. 47 by 19 will result in a remainder of 9, and that's your answer. It should not take more than 10 seconds for you to mark the answer here. 47 divided by 19, the remainder is 9, and that's your answer. Right? Of course, always it will so happen that the given number 19 here is a factor of the number 361, or 361 is a multiple of the number 19. So we don't have to worry about the first part. All you have to worry about is the second part. Yeah. So 47 by 19, remainder is 9, and that's your answer, option C. I hope all of you have understood this. Yeah. Neeraj has asked, is this the first question? Yes, it is the first question, Neeraj. I think time to move to the next one. I'm sure all of you have followed the process and You also know the SMART method. So let me present the next question to you all, which is on your screens now. Here he says, let x be the smallest number which when added to 2000 makes the resulting number divisible by 12, 16, 18 and 21. The sum of the digits of x is. So this also is a question based on the divisibility rules. Yeah, or in fact the concept of LCM and HCF. It just twisted a little bit by asking us to find out the sum of the digits of the number x. So I'll leave you with this for 45 seconds again, or maximum 1 minute. The clock starts now. Option D or option A. Okay, time to discuss this. Like I said, we don't want to spend too much time solving questions today. You should be practicing on some mock tests instead. Let's discuss this now. So the question here is, let x be the smallest number which when added to 2000 makes the resulting number divisible by 12, 16, 18 and 21. The sum of the digits of x is. So basically he says x is a number, in fact the smallest number, which when you add to 2000 it will make it divisible by 12, 16, 18 and 21. 12, 16, 18 and 21. So what is the sum of the digits of x is the question. Yeah. So it is actually this 2000 plus x should be divisible by 12, 16, 18 and 21. It should be divisible by all the four numbers here. Now let us first find out the smallest number which is divisible by these numbers here. So basically LCM, you know the concept of LCM, right? Let me not get into the details. I am looking at the LCM of 12, 16, 18 and 21. What will be the LCM of 12, 16, 18, 21? LCM of 12, 16, 18, 21 is that number which is divisible by 12, 16, 18 and 21 without any remainder. The remainder is going to be 0. So find out the LCM. You know the process, right? I mean, there are different ways of finding out the LCM. Let's go with the regular method, which is not very lengthy. I mean, if you know how to work on it, it's not very lengthy. So if you, let's say, take 2 as a, I mean, you have to consider only prime factors as much as possible here. So this is 6, 8, 9 and 21. Then I can go for, let's say, 3. So this is going to be 2, 8, 3 and 7. Then again, if I take 2 ones, I'll get 1, 4, 3 and 7. And then now I know that it's going to be 4 ones and 3 ones and 7 ones. Or maybe 2 ones and 2 ones, which is nothing but 4 ones. So I can say the answer is going to be 2 into 3, 6, into 2, 12, into 1, 12, into 4, 48, 48 into, 7 into 3 is 21, right? 48 into 21. 48 into 21 is 960 plus 48, 1008. Yeah, so LCM of these numbers is 1008. So basically 1008 is the smallest number, which is divisible by 12, 16, 18, 21. Now, what is the actual question? He says, what should you add to x so that, what should be added to 2000 so that it becomes divisible by 12, 16, 18, 21. Now, going back to the basics, you know that if a particular number is divisible by, let's say, a set of numbers, all its multiples are also divisible by the set of numbers. So if 1008 is divisible by 12, 16, 18, 21, I can also say 1008 into 2, which is 2016, is also divisible by 12, 16, 18 and 21. And in fact, after 1008, the only number that I would get, the immediately next number available is 2016, followed by 3024, 4048, 5060 and so on. All these multiples into 3, into 4 and so on. You're getting it? So all the multiples of 1008 are going to be divisible by 12, 16, 18, 21. But my focus is going to be on 2016 because I am looking at adding something to 2000. So I am looking at a number which is in the range of 2000. So 3024, 4048, 5060, all these are not of my interest. 1080 is also not of my interest. But of course, 1008 as a base is required because only from 1008 we will be able to arrive at 2016. Now, I know that 2016 is a number. 2016 is a number which is divisible by 12, 16, 18 and 21. So this 2000 plus x is actually 2016. So can I say x is equal to 16? I can conclude that x equals to 16, right? So our understanding of all this is x has to be 16. So what is the sum of the digits? What is the sum of the digits? 1 plus 6, 7. That's your answer. So option A will be the answer, 7. Let me give you another example to make it clear. Let's say instead of 2000, if he says 3000, what should be the smallest number that should be added to 3000? So then I'll consider 3024. So the number that should be added to 3000 is 24. And what is the sum of the digits of 24? 2 plus 4, 6. In that case, the answer will be C. What should be the number, let's say, when added to 4000, he says? So for 4000 to 4000, I should be adding 48. And sum of the digits of 48 is 12. So in that case, the answer will be 12 and so on. Right? Anyway, for the given question where the number is 2000, we have to add 16 and the sum of these digits is 7. See, be very careful. He is asking us to find out the sum of the digits and not x. The same question instead can be, what is the value of x? The value of x is 16, but the sum of the digits is 7. So option A is the answer. If you're clear with this, we can jump to the next one. Santosh Kumar, Yashvir, Kishore, all of you have marked 7 here. I'm sure those who had marked option D 4 as the answer are clear as to where they've gone wrong, right? Yashvir initially said 4, Neeraj said 4, right? Pramod had got 4. So Rishu also had got 4. I don't know why or how did you all arrive at 4, but answer is 7, option A 7. Clear? Should we take up the next one? Let's take up the next one. Now this again is something that you already know. You should not be spending more than 15 seconds to get the answer. However, I will give you 45 seconds. The clock is ticking now. The HCF and LCM of two numbers are 21 and 84 respectively. You should know that standard equation, right? For two numbers where LCM and HCF are given, the product of the numbers will be equal to the product of LCM and HCF. That's it. Now he says the ratio of the two numbers is 1:4. So what is the larger number? Quick. 45 seconds is what you have, but then ideally you should be able to crack this in not more than 10 seconds. Santosh Kumar says, tell us about remainder theorem. Santosh Kumar, I think what we solved in the first question today involved the concept of remainder theorem. What you can do is watch our videos. We already have videos on remainder theorem. Let's not waste our time discussing remainder theorem here. Okay. 84? Okay. So all of you have got the answer 84. Let me take this up. The HCF and LCM of two numbers are 21 and 84 respectively. If the ratio of the two numbers is 1:4, then the larger of the two numbers is. So basically it's talking about two numbers. Let's say the numbers are A and B. Right? A is to B is equal to 1:4. The ratio of two numbers is 1:4, right? Ratio of two numbers is 1:4. So I can say actually A is equal to X and B is equal to 4X. By the way, you don't have to write so much to conclude that A is X and B is 4X. I mean, that's understanding. 1:4 means X and 4X. The LCM of A and B. Again, these steps are not required, only for the sake of clear explanation I'm putting it up. LCM of A and B is 84 and the HCF of A and B, the highest common factor of A and B is equal to 21. Is equal to 21. So the larger of the two numbers is, what is the larger of the two numbers? Okay, what is the larger of the two numbers? Yeah. Now, what do? You know the concept, right? A into B should be equal to their LCM into HCF. The sum of two numbers, I mean product of two numbers is always equal to the product of their LCM and HCF. So going by this, can I say X into 4X is equal to 84 into 21? Yes. So 4 here goes 21 times. So basically I can conclude X square equals to 21 square. So X is equal to 21. X is 21. What is he asking us to find out? The larger of the two numbers. What is the larger of the two numbers? Now, larger of the two numbers is of course B only, right? Because B is 4X. So larger of the two numbers will be 4 into 21. 4 into 21. 4 into 21 is what? 84. Option D is the answer. Right? Option D is the answer. Similarly, if he says what is the smaller number? Your answer should be X, which is 21 itself. However, if anybody here has done this to arrive at the answer, I will still treat your answer as wrong. While you have got 84, which is correct, but I think your method is wrong. Your method is wrong. You cannot spend any time in marking the answer. A smart person will mark the answer to this question in about 5 seconds. And it's obvious that when I say you have to spend 5 seconds, you don't have the luxury of using pen and paper. Why do I say 5 seconds? Simple. He says that the highest common factor of the two numbers is 21 and the LCM is 84, right? If the ratio of the two numbers is 1:4, then the larger of the two numbers is. The simple point is, whatever be the larger number, it has to be a multiple of 21. Whatever be the larger number, it has to be a multiple of 21 because the highest common factor is 21, which means 21 is a factor for both A and B. When I say HCF is 21 means what? 21 is a factor for A, 21 is also a factor for B. When I say LCM is 84, 84 is a multiple of A, 84 is also a multiple of B. So my clear understanding is that whatever is the larger number, it should be a multiple of 21. Is 12 a multiple of 21? No. Is 108 a multiple of 21? No. Is 48 a multiple of 21? No. Is 84 a multiple of 21? Yes. That has to be the answer. There is no other choice. So if anybody has put pen on paper for marking the answer to this question, I'm sorry, you are not fit for the exam, or rather I would say you are not thinking divergently. You have to think in a smart way. And the smart solution is to just check with the options. Now this method will not work always. This method here is working because only one option satisfies. Suppose options are 42, right? And then 105, right? Or 210. Then it is difficult because 42 is a multiple of 21, 105 is a multiple of 21, 210 is also a multiple of 21. You're getting it? But then that way you can say 84 is not a multiple of 44 is a multiple of 42, 84 is not a multiple of 105, 210 is not a multiple of 105. 210 is not, 84 is not a multiple of 210. But then 42 and 84 both are possible. See, there is a possibility that this method will not work if options are given in a smart way. If options are 21, 42, 63, 84, then I cannot apply this method. Even then I can apply, but I will not be able to eliminate all the options. Here, I am able to eliminate all the options. I can eliminate 12, I can eliminate 108, I can eliminate 48. So why not? When there is a scope, why should I put pen on paper? 84 is the correct answer. Without putting pen on paper is a smart answer. Having done that, let me ask a question to all of you. How many of you have used this technique to get the answer? You just have to say smart or stupid. I mean, while the solution is correct, even if you have taken x, 4x, x into 4x equals to 21 into 84, you are right. But that's stupid because options will give you the answer much faster. So all of you have to comment. Unless all of you comment, I'm not going to move to the next question. You just have to comment smart or stupid. If you have followed the smart method, say smart. If you follow the stupid method, say stupid. I'm glad that Pitu and Nilab have used the smart method. Others, Yashvir has done smart, Mahata has used the regular method. So I'm also glad that Mahata used the regular method and she has learned something here. Ajit and Chandra Neeraj have also got the answer to the smart method. Good. Venkat Reddy used the regular method. Anybody else who has used the regular method? Milan used the regular method. So there's a lot of learning, at least for a few of you here, right? Chandrahas Yadav used a regular method. Vidya Rajan is upset that regular method was used. Santosh, Jiban, these guys also use the regular method. Hina, by the way, used the smart method. Karthikeyan and Sajit use regular method. Good. I'm seriously happy now. I mean, I thought all this drama that I've done will be of no use if all of you have used the smart method, right? You'll be like, boss, we already know this. Why are you teaching this? We are smart. But, you know, not all of you have used the smart method there. Yeah. So guys, you have to think divergently. I think it's easy, whether it is geometry or trigonometry or algebra or number theory or any topic. I think unless you start thinking in a different way, you'll not be able to score differently, right? I mean, if you do things like how everybody else does, then how are you going to be a part of that minority who will get called for the next round? Yeah. So it's all about the road less taken, if I have to say. Anyway, let me present the next question to you all, and here we go. This also has been solved through our earlier live sessions. I'm sure you will know the technique, and there's a common question type when it comes to SSC exams, right? The greatest number among 3 power 50, 4 power 40, 5 power 30 and 6 power 20 is. So what is the greatest number? Now, one is not expected to find out what is 3 power 50, 4 power 40 and so on, but you can do something here so that you get the answer quickly. Is it right? Option A or B? Milan got B, Hina Modi, Anuradha, Sanjana, okay, Hina Modi and Anuradha have got A, Sanjana says it's D, and there's so much of confusion here. Sajit has got B, Venkat Reddy has got B, nobody has marked C here, huh? 5 power 30 is not the greatest number, that's for sure, but some of you have said A, others have said B, and then few others have said D. How can D be the answer, by the way? Okay, D, 6 power 20 is also there. Sorry, I missed that. Greatest number among 3 power 50, 4 power 40, 5 power 30 and 6 power 20. Okay, time is up. Let's discuss the solution now. Here we go. So the greatest number among 3 power 50, 4 power 40, 5 power 30 and 6 power 20 is. Options, all the 4 have been given there. So we have to find out the greatest number. Now I'm sure the idea is not to actually evaluate what 3 power 50 is or 4 power 40 is, 5 power 30 and so on, right? That would take ages for us to simplify. So what do we do? Now, before I proceed with the solution, let me tell you the question can be asked in various forms. He can ask you to find out the greatest number, the smallest number. He can ask you to find out the ascending order of these numbers or the descending order of these numbers. But anything has the same process. Anything that has to be done has to be done using the same process. What do we do? See, 3 power 50, 4 power 40, 5 power 30, 6 power 20. The challenge is all the bases are different, all the powers are also different. If any one of these are made equal, if all the bases are equal, let's say, if everything is like 3 power 50, 3 power 40, 3 power 30 and 3 power 20, we know which is the largest number because all the bases are equal. We can simply go by the powers. But that's not possible here because all the bases are different. If all the powers are also equal, 3 power 50, 4 power 50, 5 power 50, 6 power 50, then also it's easy to decide. Larger the base, larger the value because all the powers are same. But powers are also different. So one of these have to be made equal, right? One of these have to be made equal. What do? You make the powers equal. You cannot change the base, but you can always represent the powers in such a way that the powers are equal with different bases. So what can be done? Simple. 3 power 50 can be taken as 3 power 5 whole power 10. Remember the logic. A power m whole power n is equal to a power m into n. So basically what we are doing here is 3 power 50. 50 is being taken as 5 into 10. So 3 power 5 whole power 10. See, the point is 50, 40, 30 and 20. The highest common factor is 10. 10 is a common factor for each one of them. So I'll take 10 as the power. Everything else will be brought inside. So 4 power 40 can be expressed as 4 power 4 whole power 10. 5 power 30 is 5 power 3 whole power 10. 6 power 20 is 6 power 2 whole power 10. Yes or no? 5 into 10 50, 4 into 10 40, 3 into 10 30, 2 into 10 20. Now if you observe, all the powers are equal, 10, 10, 10 and 10. So if I can simplify what is inside now, I'll be able to compare it very easily. What is 3 power 5? 3 power 5 will be 81 times 3, right? It will be 243. So this is 243 power 10. 4 power 4 is 256, right? 16 squared basically, right? So it will be 256 power 10. 5 cube is 125 power 10, and 6 squared is 36 power 10. Now compare. Don't look at the numbers as 3 power 50, 4 power 40, 5 power 13, 6 power 20. The numbers are 243 power 10, 256 power 10, 125 power 10 and 36 power 10. Yes or no? He's asking you to find out the greatest number. Which will be the greatest number? See, all the base powers are equal, right? So you can actually forget about it. Simply compare the base. Which is the greatest one? 256 is greatest. 256 came through what? 4 power 40. So option B is the answer. Suppose he says which is the smallest number? The smallest base here is 36. So smallest number. Suppose he says put the numbers in ascending order. Options will be given to you in different orders. Options will be given, different orders will be given in the options. Ascending order. What is the ascending order? Ascending order should be 36 power 10, which is 6 power 20. Less than, next comes what? 125. So 125 is 5 power 30. Less than, next comes 3 power 50. Finally comes 4 power 40 because 256 is the largest. 4 power 40. Similarly, if it is descending order, the reverse of this. So whether it is ascending order, descending order, greatest number, smallest number, answer is arrived at using the same process. Make the powers equal, right? So what do you have to consider? See, here it was simple because 50, 40, 30, 20 were given. So we know 10 is a common multiple, but just find out the highest common factor. The highest common factor for all the powers 50, 40, 30 and 20 is equal to 10. So express every power in terms of 10, take 10 outside and the other part inside the base. You get the answer. So option B, 4 power 40 is the final answer. Trust all of you have understood this. Yeah, option B is the answer, 4 power 40. Sajid says, will there be any special class on SBI clerk for TS students? Well, yes, Sajid, I think if you look at the change we have done in the calendar, I had mentioned this in my last session as well. I don't recall what session was that. I think it was on trigonometry. I am repeating myself, and I'm sure Sylvia and Gayatri also must have mentioned this to you. We have changed the way we'll be doing the live sessions going forward. It will be only for TS students, of course, all the 6 PM live sessions that we do and 11 AM live sessions that we do. We have what is called a refresher on quantitative aptitude, refresher on reasoning, and refresher on English planned on Mondays, Wednesdays, and Fridays in some order there. These refreshers will be focusing on the upcoming exams. It could be SBI exam, it could be CHSL exam. All right. So there won't be like specific to SBI clerks or anything, but yeah, we know that SBI clerks is coming up, so we'll be taking up questions related to SBI. In fact, we'll be taking up questions from the all India mock exams being conducted for SBI clerks, and all India mock exams being conducted for SSC CHSL. So whatever are upcoming exams, it could be from bank exam category or SSC exams category or government exams category. Yeah, so don't worry about it. And when we are really close to the exam, maybe we'll do one simple refresher or anything. I mean, I'm not giving a commitment there, but Mondays, Wednesdays, and Fridays are for your upcoming exams. What we do on Tuesdays and Thursdays will be concept sessions, but those are only for some students of TalentSprint who have enrolled for the Titanium program. I'm sure all of you must have got an email from TalentSprint, an SMS from TalentSprint about a launch of a new program called Titanium, right? Which will have exclusive live sessions. So every Tuesday and Thursday there will be. Today is a exception. The batch is starting from 20th onwards. 20th February the batch starts for Titanium program. 19th February in fact. So those guys will have access to all the live sessions that you will have access to. All the quant, reasoning, English refresher, doubts clarification on Saturday, current affairs on Friday. In addition to that, they will have live sessions for the topics, topic level live sessions, live session on profit and loss, live session on coding and decoding, live session on spot the error, right? And they will have a calendar which will be followed. So they'll have exclusive live sessions, plus they will have what is called a one-on-one mentoring, where they'll be able to talk to successful students over a video call and plan a strategy. Because see, when you hear it from the horse's mouth, it is different, right? I mean, I have not taken a bank exam in the last 2 years or 3 years, right? Or an SS exam in the last 2 or 3 years. So while I may preach this has to be done, I have not really applied it to myself and tested it. But there are students who have applied some strategy and who have cracked these exams and who are now working for a bank or in some government department. So if you get to talk to these people, I'm sure you will get a better strategy. They will know what the real problem is, and they'll be able to help you better. So there'll be exclusive sessions with these guys, one-on-one sessions. So only one student with one mentor, right? And we have a list of mentors there. Plus you will have access to our pen drive program, SD card program, online program. So basically that's like the superset that we have in terms of programs. So yeah, those exclusive sessions will be there, but only for Titanium guys. So just to mention and make it clear about the calendar that we'll have going forward. Okay, let me throw the next question to you all. This is on units digit. I remember to have solved a similar question, maybe with same numbers in the past, but anyway, it will be like a refresher. You have to find out the units digit in the product of 2467 whole power 153 multiplied by 341 whole power 72. So try it out. While it looks to be complex, if you know the technique, there is a process by which you can find out the unit space of any base to any power. So if you have learned the process through our videos, you will know how to solve this one. Okay, so try it out. I will leave you with this for minimum 1 minute. All right, let's take this up. So the question here says the unit digit in the product of 2467 raised to the power of 153 and 341 raised to the power of 72 is. Options are 7, 3, 9 or 1. Now looks like a complex one, but if you know the technique and the process, you'll be able to solve this in about 30-45 seconds maximum, right? So we have got two numbers here. One is 2467, which is power 153. The other one is 341 power 72, and we have to take the product of these two. So to find the unit space, I should know what's the unit space for this number and the unit space of this number. Yeah, like 341 power 72. Now you know that when this number is ending in 1, any power of it will always end in 1. You take any number that ends in 1. You take, like, let's say there is some 10-digit number, right? Like 92471 44321 whole to the power of 3749. This will end in 1. Any number that ends in 1, you multiply it any number of times you want with itself. The answer will always end with 1. So clearly the other number, the second number here, is ending in 1, right? All I have to find out is what will this number end with, right? What will this number end with? And of course, since this number is ending with 1, it becomes redundant now. Whether I multiply it or not doesn't matter. You know how unit space works, right? For example, if you have 340 or 3472 multiplied by 76 2, 9. What's the unit place? Simple. I'm sorry. Okay, hold on. Yeah. So what's the unit place here? It's simple. What do? This number ends in 2 and this number ends in 9. So 2 multiplied by 9 ends in 8. 2 into 9 is 18, right? So answer will end with 8. That's the whole idea. Now, since the second number here is ending in 1, it doesn't really matter, because whatever be the question mark, whatever comes in place of question mark here, that itself will become the answer. Yes or no? The product of these two numbers will end with the same question mark, because this number is ending in 1. If it is 2 or something, we'll have to wait and find out what this number is. Okay. So the whole question now boils down to one thing. This number 2467 whole to the power of 153 ends with what? Meaning what comes in place of question mark? 2467 whole to the power of 153 ends with what? Now there is a process that you need to follow here. See, understand, this number here ends in 7, right? 2467 is ending in 7. What do? Look at it. 7 power 1 is equal to 7. 7 squared is equal to 49. 7 cube is equal to 343. 7 power 4. Well, I don't know the value, but I'm sure that 7 power 4 will end with 1. How do I know this? Simple. 7 power 4 is equal to 7 cube into 7. 7 power 4 is 7 cube into 7. What is 7 cube? 7 cube is 343. 343 into 7. You understand? 7 power 4 is equal to 7 cube into 7, which is 343 into 7. Again, applying the unit place method, number ends in 3, number ends in 7. Their product will end with 1. Again, if I look at 7 power 5, it is 7 power 4 into 7. So 1 into 7, 7. 7 power 6, 7 into 7, 9. 49, so ends in 9, and so on. Now, so this is what we have, right? This is what we have. If you look at 7 power 1 to 7 power 6, and you can continue this further. 7 power 7 will end with 3, and so. So look at the pattern here, unit place pattern, 7, 9, 3, 1. Again, you'll have 7, 9, followed by 3, 1. It will continue 7, 9, 3, 1, 7, 9, 3, 1, 7, 9, 3, 1. So first of all, we have to find out this pattern. So the pattern here is this: 7, 9, 3. Forget about everything else. I'm not worried about what the other digits are. Only the unit place: 7, 9, 3, 1. It will continue 7, 9, 3, 1, and so on. So I can find that the unit spaces are going to repeat after every 4 powers. You see, 7 comes again after 4th power. Every 4th power is, after every 4 powers, you'll get the same 7. After every 4 powers, you'll get 9, and so on. So that number is important. That cyclicity is important, right? So I can say that the cyclicity here is 4. After every 4 powers, the same unit space comes at. We will arrive at the same unit space. Yeah. And you don't really have to check so much. If you can remember that the cyclicity for 7 is 4, you are done. You don't have to do all this in the exam. 7931, then 7931, and so on. So likewise, every digit will have a cyclicity. Like for example, if you look at 6, the cyclicity for 6 is 1, because any power of 6 ends always in 6. Let me take it up on the right hand side here. Right? Let me just show it to you. Similarly, let's say we have to do it for 6. What do? The cyclicity for 6 is 1, because you take any power of 6, it always ends in 6. What is 6 power 1? 6. 6 squared, 36. 6 cube, 216. Yes or no? Cyclicity for 6. 6 power 1 is 6. 6 square is ending in 6, right? 36. 6 cube, 216, ends in 6. So if you observe 6, always it is going to be 6. So cyclicity here is 1 for 6. Similarly, let's say you have to find out the cyclicity for other numbers. Just continue. 9 power 1. Let's say cyclicity for 9. Like here we are considering 7. You have to find out the cyclicity for 9. What do? 9 power 1 is 9. 9 squared, 81, so 1. 9 cube, again 729, so 9. Again 9 power 4 will be 1. 9 into 9 ends in 1. So 9, 1, 9, 1, 9, 1, and so on. Right? Cyclicity for 9 is 2. So this is what is very, very important for you to find out. Okay. So if you can remember all the cyclicity by heart from 1 to 7, you are done. Half of the problem is already solved. So cyclicity is 4. Now what's the next step? So first step is find out the cyclicity. What's the next step? Look at the power. Power is 153. Divide 153 by 4. Divide 153 by 4. 153 comes from the power. 4 in the denominator comes from the cyclicity. Divide 153 by 4. And find out what is the remainder. Find out what is the remainder. So when you divide 153 by 4, the remainder comes out to be 1. Because 152 is divisible by 4. 152 by 4 will be how many times? I think 38 times, right? So it goes 38 times, remainder is 1. This remainder is very, very important. Second step is find out the remainder. Remainder is 1. Now because the remainder is 1, look at 7 power 1. Connect back here. 7 power 1 ends with what? 7. So this number also will end with 7. So 7 into 1. One number ends in 7, the other number ends in 1. The product of these two will end with 7. 7 into 1, 7. Suppose the remainder, let me take another case now. For example, right, like just changing the color so that you can follow. Let's say the power instead of 153 is 162 or 160, let's say 160 by 4, or let's say 161 by I'll take 160 also. Let me take a 163 first. 163 by 4, right? Power is 163 by 4. What is the remainder? Remainder is 3, right? 163 when you divide by 4. Now 3, because it is 3, look at 7 power 3. 7 power 3 ends with what? 3. So this number will end with 3. This number will end with 3. Suppose the number is 160 by 4. What's the remainder? What's the remainder? 160 by 4, remainder is 0. Now remainder 0 is not there at all. What do we do? You understand? Remainder 0 is not there at all. So what do you do? 160 is divided by 4. What is the remainder? 0, because 160 is perfectly divisible. In that case, what will you consider? See, remainder 0 is equivalent to remainder being 4. You understand? Or equivalent to remainder being 8 and so on. Because you're dividing by 4, right? See, first of all, can the remainder be 4? When you're dividing, like for example, 164 by 4. The remainder is 0. The point is 164 is the fourth multiple of 4. I mean, the power is like 164 can be taken as 21 into 4. You're able to follow? So just remember, if the remainder is 0, consider the cyclicity. I mean, 7 power 4. 7 power 4 ends with what? 1. So this number also will end with 1. You understand? That's the whole idea. So what are the steps? Step number 1, take the unit space, find out the cyclicity. If you can learn the cyclicity by heart, nothing like it. Divide the power by that cyclicity value and find out the remainder. Whatever is the remainder, consider that power, and that unit space will be filling up the gap. Alright, so option A, 7 is going to be the answer. Right, option A, 7 is going to be the answer, because first number ends in 7, second number ends in 1, their product will end with 7. Option A is the answer. I hope all of you have understood this. Yeah, I mean, the fact that all of you have got the answer 7 already tells me that you know the process, right? Santosh Kumar, Kishan, Vidyarajan, we have Jiban Kumar, Nilab, Kishan, Venkat Reddy had marked 3. So Venkat, I hope you have corrected the error wherever you have made it. And then we have Amit Sharma, Sanjana, Pittu, Hina, all these guys who got 7. Right? Should we take up the next one now? Any questions anywhere? So check out the cyclicity for every number. I mean, like 4 power 1 is 4, 4 power 2, 6, 4 power 3, again 4. You understand? So cyclicity for 4 is going to be 2, 4, 6, 4, 6, 4, 6, and so on. You can consider 7 power 0 also. I mean, Srikanth says because the remainder is 0, take 7 power 0. 7 power 0 is 1. Rishu says if the remainder is 0, then should we consider 7 power 4, which unit digit is 1? Please clear this. Yes. So remainder is 0. Remainder is 0 means what? I mean, understand the whole process, right? When you're dividing by when you're dividing a number by 4, what is the maximum remainder that you can get? General understanding. When you're dividing a number by 4, the maximum remainder that you can get is 3. Yes or no? When you're dividing a number by 4, the maximum remainder that you can get is 3. You cannot get a remainder 4, right? Because what do you mean by remainder? Remainder is like remaining, whatever is remaining, extra, which is not divisible. When you're dividing by 4, how can 4 be extra? If it is extra is 4, I can again divide it by 4 by one time and add that to the quotient, right? So maximum remainder when you're dividing a number by 4 can be 3. It cannot be 4. Remainder 0 is like getting 4, right? I mean, when will you get the remainder 0? If it is 4, I'll divide by 4, my remainder will be 0. It is perfectly divisible. You understand? That's how you can connect it. Suppose you're dividing a number by, let's say 16. The maximum remainder can be 15. You cannot get a remainder more than 15, right? When you're dividing something by 16, the maximum remainder that is possible is 15, right? Can the remainder be 16? Not possible. How can 16 be remaining? Because if 16 is remaining, that 16 can be further divided by 16 one time, right? So maximum remainder that you can get is 15 there. Now suppose the remainder is 0. Consider that 16. I mean, it's like 16, right? Remainder is 16, means remainder is 0. You understand? So that's how I was connecting it back to 7 power 4. Consider 7 power 4. That's the idea. Okay, and Santosh Kumar says, what is a generalized formula? See, if you want, they can devise a generalized formula, but I don't remember or don't recall having a generalized formula for such type of questions. There cannot be a shortcut. You have to follow this process. You can cut down the number of steps by, let's say, by remembering all the cyclicities. I mean, if you know what is a cycle at which it repeats, right? That's one way. Second way is maybe if you can just remember 7 power, remainder being 1, what's the unit place, remainder being 2, what's the unit place, remainder 3, what's the unit place. But I don't believe in all this, honestly, right? You should know the concept and you should be able to do the solution using that concept as quickly as possible without having to learn any formula as such. Okay. So net, what I'm saying is I don't have a generalized formula for this. I think this is the best method. It works for any type of question that is asked here. I mean, any type of question in this format. Yeah. If that's clear, let me choose the next one. Should we take up the next one? Okay, let's take the next question. Here we go. Find that smallest 6-digit number. Find that smallest 6-digit number which when divided by 9, 12, 21 and 25 leaves no remainder. Simple one. Done. Neeraj has got 1,08,000 and so has Mahata and others there, right? Chalo, let's discuss. See what it says. Yeah. Find that smallest 6-digit number which when divided by 9, 12, 21 and 25 leaves no remainder. Now this is a general question type. The only challenge here is he's talking about a smallest 6-digit number, right? Smallest 6-digit number. So 6-digit is a little bit of concern here. But for a moment, let's forget about 6-digit. Let's forget about this part. Read the question again. Find that smallest number which when divided by 9, 12, 21 and 25 leaves no remainder. So if you neglect 6-digit here, the smallest number which is divisible by the given set of numbers is the LCM of those numbers, right? LCM means what? Least common multiple. So smallest number here is nothing but the LCM, right? LCM. Least is smallest, common multiple for these values, right? So basically smallest number. Let's first find out the smallest number. What is the smallest number? It is equal to the LCM of 9, 12, 21 and 25. Now different ways of taking the LCM, you can follow whichever is most convenient to you. I mean, some students like to do by factorization, others like to just follow the regular method. So let's do the LCM 9, 12, 21 and 25. Of course 25 can directly be taken because nothing else is a factor of 25 here, or I can take 5 twice. That doesn't really matter whether I take 5 twice or 25 once. It's not going to make any difference. You understand? The problem would have been if there is one more number which has a 5 as a factor, then you should not be taking 5 square directly. Yeah. Anyway, assuming all of you know those basics, let's start with 3. So this is 3, 4, 7 and 25. Now I'm very clear that I have to take 3 ones so that this 3 goes out. I have to take 4 ones so that 4 goes out, 7 ones and then 25 ones, because all these are unique factors now. There is nothing common there. So what's the number? 3 into 3, 9. 9 into 4. You're getting it? 3 into 3, 9. 9 times 4, 36. 36 into 7 into 25. Yeah. So this is equal to, 3 into 3 into 4 into 7 into 25. I think what I'll do is, instead of multiplying 3 into 3 into 4, I know 4 into 25 is 100. So my life becomes easy. 3 into 3, 9. 9 into 7. 9 into 7 is 63. Yeah. So this becomes 6,300. Right? LCM is equal to 6,300. Now, I know that 6,300 is the smallest number which is divisible by 9, 12, 21 and 25. But now we have to find out the smallest 6-digit number. Now consider the 6-digit part here. So let me include 6-digit. Now what happens? Smallest 6-digit number. What do you have to do? Simple. Just to go by kind of trial and error. Smallest. You don't really have to waste too much time here. Smallest 6-digit number. So for that to happen, you have to take multiples of 6,300. So which multiple of 6,300? Which multiple of 6,300 will give you the smallest 6-digit number? This is a 4-digit number. Which multiple will give it to you? Now see, 6,300 into, if I take 100, I will be in 6,30,000 range. So I don't have to go to that. You understand? We are looking at a 1 lakh kind of a range, right? So 6,300 into, let's say 10, it is only 63,000. So it doesn't help, I have to go further, right? I mean, if I have to get a 6-digit number, see, smallest 6-digit number is what? It is 1 lakh. Smallest 6-digit number is 1 lakh. But smallest 6-digit number which is divisible by these numbers need not be 1 lakh. It should be something more than 1 lakh, 1 lakh or something more than 1 lakh. So 63,000 does not work. Into 15 if I do. So 63,000 plus 31,500, that will be like 94,500. But this also doesn't do. So maybe I think if I add one more 6,300, which is taking 16 multiple, it will help. So it will be 1,800,000. That's the answer. 1,800,000. Option C is the answer. You're able to follow? 1,800,000. That's the answer. So this is how you solve it. You understand? First find out the LCM, then take multiples of LCM into 10, into 15. So into 10 when I took, I got only 63,000. I'm not anywhere close to the smallest 6-digit number, which is 1 lakh. Into 15 when I do, I come close to 1 lakh, 94,500. So I'll try with into 16. Into 16 is crossing 1 lakh. That's it. If into 16 is also not crossing 1 lakh, then I'll go for into 70. Right? So this is how you know what's the smallest 6-digit number which is divisible by these numbers without giving any reminder. So 1,800,000 is a final answer. Now, is this the only way to solve the question? No. This is the regular way of solving the question. The other way is go by options. Just go by options. You can go by options and eliminate all the unnecessary answers. Like for example, whatever be the correct answer, it has to be divisible by 9, 12, 21 and 25. Right? Now you know the divisibility rules for 9, 12, 21 and 25, right? You can apply those. Like for example, option 1 is straight away eliminated because it is not divisible by 25. For a number to be divisible by 25, it should be ending with 25 or 50 or 75 or 2 zeros. So first option cannot be the answer at all. I mean, I'm explaining the smart method. Let me use a different color. Smart method, first option cannot be the answer at all. Why? It is not divisible by 25. For a number to be divisible by 25, it should end with 25 or 50 or 75 or 2 zeros. This we have already learned. Now if you look at the remaining numbers, possible 25, 2 zeros, 2 zeros. So only one option got eliminated. Then apply the other divisibility rules. Like for example, divisibility rule for 9. What's the divisibility rule for 9? Sum of the digits. If the sum of the digits are divisible by 9, the number is also divisible by 9. Yes or no? So check for sum of the digits. So if I look at second option, first option is already eliminated. Second option, 1 plus 2 plus 2 plus 5. So sum of the digits here is what? 3 plus 2, 5 plus 5, 10. Is the sum of the digits divisible by 9? No. 10 is not divisible by 9. So option B is also eliminated. Option C, yes. 1 plus 8. Sum of the digits is 9. Possible. Option D, 1 plus 1, only 2. Sum of the digits here is 2. Is 2 divisible by 9? No. So option D is also eliminated. So I can also go by options. I can go by options, apply divisibility rules and check which one satisfies. But if you have to follow the regular method, this is what you need to do. And I'm of the view that regular method is also important. You should know what is the regular method. And then you can apply smart techniques. So by smart way, option C is the answer because that's the only option. That's the only option which is divisible by 9. In fact, first option also is not divisible by 9. So hence option C is the answer. But if multiple options satisfy this, then you may have a little bit of problem where you can apply this technique. Yeah, elimination of course always is the best method. You can follow that, but not at the cost of not knowing the regular method. You should know the regular method. Regular method is also important. Now let me change the question a little bit. For example, if let's say the question says instead of no remainder leaves let's say 15 remainder. Some remainder is given. Instead of saying no remainder, it says it leaves 15 as a remainder, or it leaves something as a remainder. What happens? The answer should be 1,800,000 plus 15. See, no remainder and with remainder, without remainder, with remainder, the only difference is because he said no remainder, we added 0 to 6,300. You're able to follow. So suppose he says with 15 remainder, we have to consider 6,300 plus 15, plus 15, plus 15, plus 15 and so on. That's the only difference. You're able to follow. So that clarity has to be there. Because he said no remainder, we are adding 0, plus 0, plus 0, plus 0, plus 0, which means actually the same number itself. But when there is a remainder, whatever be that remainder, instead of 15, let's say it is R, some remainder, leaves R remainder. You just have to add R to the value that you consider. Whether it is a LCM or smallest 6-digit number, smallest 5-digit number or whatever, you just have to add R. So that clarity has to be there. Conceptual clarity has to be there. Okay. So I hope this is clear to all of you. Can we now go to the next one? Yeah, all of you got option C. And I'm assuming all of you use the smart method of checking by, you know, those values given there, right? Applying those divisibility rules. Let's take up the next one. Similar question, but with a difference now. Find the least possible 5-digit number. This time is talking about a 5-digit number, which when divided by 10, 12, 16, 18, leaves remainder 27. So same as previous question with one extra step. This time the remainder is 27. You know what needs to be done, right? So try it out quickly. Time is up. Let's look at the solution now. So here it says find the least possible 5-digit number which when divided by 10, 12, 16 and 18 leaves remainder 27. I'm sure all of you know the method, right? I mean, the regular method is to find out the, see, we are looking at what, forget about the least possible 5-digit number, forget about 5-digit for some time, right? Find out the least possible number which when divided by 10, 12, 16 and 18, see, instead of least remainder 27, let's say remainder is 0. So basically first step is to find the LCM of 10, 12, 16 and 18, right? You know, LCM of 10, 12, 16 and 18 will give you that number which is perfectly divisible by 10, 12, 16 and 18. Then we will consider how to, you know, consider the fact that it is giving a remainder of 27, then 5-digit number and all that case, right? So let's check it out. So first of all, LCM of 10, 12, 16, 18, 10, 12, 16, 18, right? So if you take 2, let's say this is 5 times, 6 times, 8 times and 9 times, right? Another 2 if you take 5, 3, 4 and 9. If you take 3 here, again it will be 5, 1, 4 and 3. And now you know, anyway you'll have to kind of repeat the process, right? Like 5 has to be taken once, then 4 and then 3. So what is LCM? 2 into 2, 4, into 3, 12, into 5, 60, into 4, 240, into 3, 720. So 720. Which means 720 is divisible by 10, 12, 16 and 18. Suppose if this 5-digit part is not given at all, find the least possible number which when divided by 10, 12, 16 and 18 leaves remainder 27. What will you do? Our answer will be LCM plus 27. LCM plus remainder. So 720 plus 27, 747 would have been the answer, right? But then there is an extra step. There has to be a 5-digit number. So let's consider that part now. How do you do that? Simple. First of all, let's take multiples of 720. See, never take multiples of 747. You cannot be considering multiples of 747. You have to take multiples of 720 and then finally add 27 to the answer. Right? Some students commit this mistake. They take multiples of 747 and find out which is as close as possible to a 5-digit number. That's not the process. Take multiples of 720. So smallest, now we are looking at smallest 5-digit number. Smallest 5-digit number. Right? So what happens? Multiples of 720. So 720 into I think into 10 is 7,200. See, smallest 5-digit number you know is 10,000, right? So I'm looking at something in this range. Yeah. So in the 10,000 range, 7,200. 720 into 15 will be 10,800. Yeah. So it has crossed the 10,000 range. So I think it should be 720 into 14. So 10,800 minus 720, 10,080 will be the value. Yes or no? Smallest. So this cannot be considered, this cannot be considered because this is less than 10,000, not a 5-digit number. This is a 5-digit number, but I know that if I subtract 720 from this, which means if I take 14 multiple, even then I'll be getting a number which is greater than 10,000. So 10,080 is the value. But 10,080 is what value? 10,080 is the value which is divisible by 10, 12, 16 and 18. We want the remainder to be 27, right? So final answer will be what? 10,080 plus 27. Which is 10,127. 10,127. 10,120. Sorry, hold on. 10,080. 10,080 plus 107. I'm sorry, I made a mistake. My bad. 10,080 plus 27, 10,107. I'm so sorry. So 10,107. Option A will be the final answer. Option A is going to be the final answer. Right? Now, is this the only way you do it? No, definitely not. There are smarter ways of solving the question. So let me explain the SMART method. What is the SMART method? Go by options. You don't have to do all this. This method is correct, right? But how do you do it? Using options. Simple. First of all, subtract 27 from all the options. Why do you have to subtract 27? Because these options include the remainder 27. You understand? We are looking for a smallest possible 5-digit number, which when you divide by 10, 12, 16 and 18 leaves remainder 27. Which means this number will include the remainder 27. So subtract 27 from all the options. That's the first step. And then check for divisibility rules. As simple as that. So 10,107 minus 27 is 10,080. right? Then 10,100 minus 27 will be 10,073. 10,027 minus 27 is 10,000 itself. And 507 will be 10,480. So these are the values. Why did we subtract 27? Because these numbers include 27 remainder. So subtract 27 and then check for divisibility rules. So check for 10. 10, 12, 16, 18 are the numbers, right? A number is divisible by 10 only if it ends in 0. So possible. Not possible, because this does not end in 0. Possible. This also is possible. So one option is eliminated. Going by the divisibility rule of 10, option B is eliminated because it is ending in 3. A number is divisible by 10 only if it ends in 0. So 10,080 is possible, 10,000 is possible, 10,480 is also possible. Now you have to check for 12, 16, 18, which is a little difficult task. I mean, maybe you can actually divide and find out. That's one way of doing it. Or you have to go for divisibility rules. Like for example, you know that the divisibility rule for 12 is what? A number is divisible by 12 if and only if it is divisible by 3 and divisible by 4. These are 3 and 4 are co-primes. Again, there's a whole lot of concept involved here. I'm hoping all of you have gone through our videos. Right? If you go by our videos on LCM and HCF, we have discussed about divisibility rules. So number is divisible by 12 if it is divisible by 3 and divisible by 4. So now we can check for divisibility rule for 12. So which means I should check for 3 and I should check for 4. Now is the first number 10,080 divisible by 3? Yes. Divisibility for 3 is what? Sum of digits. Yes or no? And what's the divisibility rule for 4? Last two digits must be divisible by 4. So apply that concept now. So first number 10,080 is the sum of the digits divisible by 3? Yes. 1 plus 8, 9 divisible by 3. Is the number divisible by 4? Yes. Last two digits are 80 divisible by 4. So this number is divisible by both 3 and 4. So which means this number is divisible by 12. So I cannot mark this as the answer. I have to verify other options. Option B is already eliminated. Look at option C. What is option C? Option C here is 10,000. Is 10,000 divisible by 3? No. Because sum of the digits here is 1. 1 is not divisible by 3. So this number is not divisible by 3. If this number is not divisible by 3, it is not divisible by 12. So option C is eliminated. Look at option D. Is 10,480 divisible by 3? No. Because sum of the digits here is 1 plus 4 plus 8. 1 plus 4, 5. 5 plus 8 is 13. Is 13 divisible by 3? No. Since 13 is not divisible by 3, 10,480 is not divisible by 3. And if 10,480 is not divisible by 3, it is not divisible by 12. So D is also eliminated. So B, C, D are eliminated. Hence option A is the answer. Now I can confidently mark option A is the answer. So this is a smart method. Smart method is to go by divisibility rules for 10, 12, 16 and 18. However, consider the fact that here there is a remainder of 12 which has to be subtracted from all the options first. Okay. So option A, 10,080 is the final answer. Yeah, I think Chandra has applied the divisibility rule for 18. I have applied it for 12. Either ways, you get the same answer. You are saying 10,080 is the only number which is divisible by 9. Hence, that is the only number divisible by 18. Hence, that's the answer. I am saying 10,080 is the only number which is divisible by 3. Hence, that's the only number divisible by 12. And hence, that's the answer. So, there are multiple ways. But eventually, I mean, overall, finally, if you look at it, what are we using? We are using the concept of eliminating the wrong answers. How are we doing that? By using the options. Okay. Should we take up the next one? Let me present the next question. I think I have got another question which is similar to what we have solved in the beginning of the session. I'll give you only 15 seconds after I present the question. I want all of you to be ready. All of you tell me ready, you are ready, then I'll present the question, and then you have just not even 15 seconds, I think 5 seconds. On the count of 5, you should mark the answer. Of course, depending on your internet connectivity, you may take a few seconds longer, a few seconds more. But if all of you are ready, I'll present the question, I'll count 5 and you should tell me the answer. I mean, that's the speed I'm looking at. So, are you ready? Shrikant is ready, Chandras Yadav, Venkat, Neeraj, Pittu, Anuradha and others. Good. So, this is like a phone a friend in KBC, right? After the question is presented, only 30 seconds. So, 5 seconds after I present the question. Or maybe 10 seconds because you will take 5 seconds to read the question. So 10 seconds. On the count of 10, I want all of you to mark the answer, and here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, I've got 3 answers. Karthikeyan, Shrikant and Mahata. All 3 of them had marked D, 0. Shrikant has marked C, Abhishek has marked D, Kishore has marked C, Ajit has marked C. Yeah, so the first 3 responses were Karthikeyan marked 6, not D. Karthikeyan marked 6, Shrikant and Mahata marked D, which is 0. Anyway, good to see that reaction. I think many of you, in fact most of you, have got C as the answer. Looks like some of you have committed a mistake while marking it as D. Here's a question. If a number is divided by 102 and leaves a remainder 91, if this number is divided by 17, then the remainder will be. What do you do? Divide 91 by 17. 91 when you divide by 17, 85 is divisible, 6 is the remainder, so 6 is the answer. As simple as that. Don't ask me how, why and all that. We have solved this question multiple times already. In fact, once in this session itself. C, 6 is the answer. And that's the amount of time you have to spend. Look at the remainder in the first case. Divide that remainder by the divisor in the second case. Whatever is the new remainder, that's your answer. It takes about 4 to 5 seconds. Yeah. Let me show the next question now. This is interesting. I think I'll leave you with this question for about 1 to 2 minutes to see how many of you are able to crack it. Your clock starts ticking now. 94 cube minus 23 cube minus 71 cube is at least divisible by 71 and 23, 23 and 74, 71 and 94, 23, 71 or 94. Try it out. 2 minutes. Let's see how many of you get the right answer. And by the way, Rohit Sharma has completed his century in the match today. Good to know that. Okay, I don't want you guys to get distracted. Solve. Some of you have marked D, and Nilab very rightly says, "Bahar mein jaye cricket." Abhi kisi ko cricket nahi dekhna, right? Waiting for more answers. Okay, let's discuss now. I think enough time has been given. Here we go. So here's the question. 94 cube minus 23 cube minus 71 cube is at least divisible by. Options are 71 and 23, 23 and 74, 71 and 94, 23, 71 and 94. Now one way to solve the question is to find out 94 cube, 23 cube, 71 cube, simplify and get the number, and then check if that number is divisible by these values or not, and you will be able to figure out what the answer is. I mean, option is, but that's not the ideal solution, right? It will take too much of time. I mean, finding out 94 cube itself will take you some time, and then 23 cube, 71 cube, then finding out the arithmetic sum of these three or whatever the difference that has to be calculated, and then checking by options, right? So that's not the method to be followed. That's not the ideal method to be followed, I would say. Instead, something smart can be done. For example, look at this. The given value is 94 cube minus 23 cube minus 71 cube. Now, this can be expressed as, I mean, look at this. I can take 94 cube minus 23 cube as the first set. It becomes what? In the form of a cube minus b cube. So if it is a cube minus b cube, it will be what? A minus b, 94 minus 23 into a squared plus ab plus b squared minus 71 cube. Now if you observe, the first term is this and the second term is this. 71 cube as it is. The first two terms, 94 cube minus 23 cube, have been expanded using the formula a cube minus b cube, right? Recall what is a cube minus b cube? A cube minus b cube is equal to a minus b into a squared plus ab plus b squared. So that's what I'm doing there, right? Algebraic expansion. Now what is 94 minus 23? It is 71. If you observe the first term, I mean, I am not worried about what this part is. I don't even want to bother about this. I don't care what this is. All I know is it is getting multiplied by 71. So the first term is divisible by 71. And second term, of course, since it is 71 cube, is also divisible by 71. So can I say the overall number is divisible by 71 perfectly? Yes. First term has got 71, second term has also got 71. So it is divisible by 71. So is it at least divisible by 71? Yes. 71 here. Yeah. But second term has not got 71, eliminated. Third term has got 71, option has got 71, possible. Fourth option has also got 71. Now this is one way of looking at it. Now take the same number, 94 cube. What I'll do this time is I'll take 71 cube ahead and minus 23 cube. I'm taking the same number, I'm just positioning it. 71 cube this side. So what happens now, it becomes 94 cube minus 71 cube minus 23 cube. Again, if I take this in the form of a cube minus b cube, I'll get 94 minus 71 into 94 squared plus 94 into 71 plus 71. I mean, see, if you have understood the concept, you don't have to actually write this. You will understand that 94 minus 71 results in 23 minus 23 cube. So this is 23 multiplied by something, and this is also 23 multiplied by 23 multiplied by 23. So both the terms are divisible by 23. So the overall result will always be divisible by 23. So 71 and 23. Here it is, this is anyway eliminated. Here 23 we don't have, so option C is eliminated. Option D also is 23. Now the only thing that you have to check is, see, 71 and 23 are available in both the options. 71 and 23 is there in option A. It's also available in option D. Option B and C are eliminated. The only thing is check for 94. How do you check for 94? Just simple. The same number, 94 cube. What I'll do this time is I'll take minus common. So I'll have 23 cube plus 71 cube. Minus 23 cube minus 71 cube. I mean, I've taken minus common. This time, 94 cube as it is, I can use the a cube plus b cube expansion. That will be 23 plus 71 into 23 square, and I'm not worried about this part because I know anyway 23 plus 71 is 94. So what do you see? The first term is divisible by 94, second term is also divisible by 94. So can I say this is divisible by 94? Yes. So 94 also should be included, which means option is eliminated, and hence option D is the answer. I don't have to put pen on paper to solve this really. I mean, see, this is for the sake of explanation. The number of steps that I've put on paper here is only for your explanation. Otherwise, how do you solve it in the exam? Smart way. Just look at it. I know that difference of 94 and 23 results in 71. Difference of 94 and 71 results in 23. Sum of 23 and 71 results in 94, which means the number will be divisible by 94, 23, 71. Understand? All these are cubic expansions, right? So I am using a plus b cube or a cube plus b cube or a cube minus b cube expansion. All you should know is this expansion. A cube plus b cube is equal to a plus b into a squared minus ab plus b squared. And a cube minus b cube equals to a minus b into a squared plus ab plus b squared. And this definitely, I mean, you definitely must know these formulae, otherwise you can't solve such questions in a smart way. So all I know is if I take a cube plus b cube or a cube minus b cube form, I'll be getting a plus b or a minus b as one of the terms. I'm not worried about this part, so don't worry and waste your time in expanding this or even writing it. You should not even write this. 94 minus 23, 71. 94 minus 71, 23, and 23 plus 71, 94. All these are there. Yeah. Sorry. So the answer to this question will be option D, 23, 71, and 94. All three divide these numbers. Followed, D is the answer, 23, 71, and 94. Yeah. I think Chandrahas Yadav and Amit Sharma have got it right. We have to use the a cube minus b cube expansion and also a cube plus b cube. You guys did not mention a cube plus b cube, but we have to use that as well. So this is clear to you all. I can present the next one. I think time is up, 7:30. I wanted to close. Maybe just one or two more questions and then we'll pack it. Take up the next one. Okay, next question. Here's the next one, quick. Find the total number of prime factors in 2 power 17 into 16 power 31 into 7 power 5 into 10 power 11 into 11 power 10 into 323 power 23. Quick. Okay, let us discuss this now. Here we go. Find the total number of prime factors in 2 power 17 into 16 power 31 into 7 power 5 into 10 power 11 into 11 power 10 into 323 power 23. Now this is a standard question type, right? What is he asking us to find out? Total number of prime factors. Total number of prime factors in the given expression. What is the expression? 2 power 17 into 16 power 31 into 7 power 5 into 10 power 11 into 11 power 10 into 323 power 23. Understand, for you to find out the total number of prime factors, first of all the bases have to be prime numbers. Here not all the bases are prime numbers, like 16 is not a prime number, 10 is not a prime number, 323 also is not a prime number, right? How do you express 323? I think 340 minus 17, right? This is 17 into 19. Yeah, so let's first express all the bases as prime numbers. So 2 power 17 as it is, 16 can be taken as 2 power 4 whole power 31 into 7 power 5 into 10 can be taken as 2 into 5 whole power 11, 11 power 10 is 11 power 10 into 323 can be taken as 17 into 19, both of which are prime numbers, right? Whole power 23. Now expand this properly. See, 2 power 17, 2 power 4 whole power 31 is 2 power 4 into 31, right? 4 into 31 is 124. 7 power 5. This 2 into 5 whole power 11 can be taken as, if you understand, this is 2 power 11 into 5 power 11. Similarly, this is 17 power 23 into 19 power 23. I mean, all this is understanding, right? A into m whole power n, sorry, a into b whole power n is equal to a power n into b power n. That's it. Now, total number of total prime factors. Once you have expressed every base, see 2, 7, 2, 5, 11, 17, 19. Once you have expressed every base as a prime number, the total number of prime factors is simply the sum of all the powers. So 17 plus 124 plus 5 plus 11 plus 11. Understand, twice. That's why I expanded this. 2 power 11 into 5 power 11. So 11 and 11 here. Plus 11 power 10, right? 10 plus 23 plus 23. Find out the sum and that will give you the answer. So 17 plus 124 is 141, 146, 157, 169, 179 and 46. So 179 plus 6 is 185 plus 40 is 225. Why am I getting 225? Okay, hold. Let me just check the sum again. 17 and 124, right? 141, 146, 157. Oh, sorry, this is 168. 168, 178, 178 and 23 is 201 and 23 is 224. Yes. So 224 is the sum. Option D is the answer. Okay. 224 is the final answer. Remember, the same question can be asked slightly differently. He says unique prime factors. Sometimes he says how many unique prime factors are there. See, these are all, what are we doing? We are counting how many times 2 comes. 2 here comes 17 times. So 17 times 2 and each 2 is like a prime factor, right? See, total prime factors and unique prime factors, there is different. Unique prime factors are how many? Unique prime factors are nothing but unique bases. Unique base values. How many unique base values do we have here? Count of 2 is the base value. See, again 2 should not be considered. Then 7, then 5, 11, 17 and 19. Any other unique thing? No. See, 2 has been considered. This 2 is already considered. See, don't count 2 twice, because actually 2 power 17 into 2 power 124 is 2 power 141. When the bases are equal, powers can be added, right? So don't count unique, he says, right? How many are unique? So 2 can be taken only once. 7 can be taken. Here we get 5. Then we get 11. Here we get 17 and 19. So count of this. What's the count of all these values? 1, 2, 3, 4, 5, 6. 6. Right? So remember, if the question says how many unique prime factors are there in this one, your answer should be 6. How many total prime factors are there in the given expression? Your answer should be sum of all the powers when the bases are expressed in the prime numbers. So option D, 224 is the answer. But one additional point that you have to remember is if he says unique, then you should count only the unique bases that we have. Okay. I hope all of you have understood. I mean, you've got 224 as the answer, but then you should also know that the same question can be asked in a different way. Pittu says, अरे मैंने 323 को 3 prime numbers count कर लिया था. 3 prime numbers कहाँ से हो गए? 3, 2 and 3, हाँ? No. 323 number दिया गया ना. It's not 3 into 2 into 3. Anyway, should we go for the next one now? Let me present the next question. Solve this one. Find the total number of different prime factors in 12 power 17, 26 power 31, 17 power 5, 899 power 11, 121 power 10. Quick. Done? Okay, time is up. Let's look at the solution now. Here we go. Find the total number of different prime factors in 12 power 17 into 26 power 31 into 17 power 5 into 899 power 11 into 121 power 10. Focus on the word different. Different here implies unique, right? He's not asking us to find out the total number of prime factors. He's asking us to find out the total number of different prime factors, unique prime factors. What do we do? Look at the expression. 12 power 17 into 26 power 31 into 17 power 5 into 899 is gonna take some time. I don't know if it is a prime number or not, into 121 power 10. Now we have to express this, I mean, we have to convert this expression into only, bases of prime numbers. So 12 can be taken as 2 into 2 into 3 whole power 17, right? 2 into 2, 4 into 3, 12. Into 26 itself is a prime, no, 26 is not a prime number. It is 2 into 13 power 31, right? 2 into 13 is 26. 2 is a prime number, 13 is a prime number. Into 17 itself is a prime number. Into 899 is a prime number. 899, 930. No, I think, see, there's no way to directly tell whether a number is prime or not. You have to do the factorization. I think 899, when you try and factorize, you'll find that it's a little difficult job, but you have to do it. There's no other way out, right? 899, I think it's 31 into 29. Just check. Yeah. Because I am looking at 899 as 900 minus 1. I'll tell you how I got 31 into 29. I took 899 as 900 minus 1. 900 minus 1 is 30 square minus 1 square. Now I know a square minus b square is a plus b into a minus b. So I got to know that yes, this can be expressed as 31 into 29. And the fact that the number 899 can be expressed as 31 into 29 tells me that it's not a prime number. Because otherwise this number cannot be expressed in any other form at all. If it is a prime number, the only way to factorize it is 1 into the number itself. So I can say 899 is 31 into 29, and 31 and 29 both are prime numbers, yes or no? Power 11 into 121 is 11 squared whole power 10. This then will get multiplied. Yeah. Now we have to find out the number of unique prime factors. Remember, the powers are not important. If he says total number of prime factors, then all the powers have to be added. But since he says unique prime factors, I only have to worry about bases. So what are the unique or different prime factors? Unique or different prime factors. What are the unique or different prime factors? Find out. 2 is there. 3 is there. Right? So I'll forget about all 2s and 3s. 13, of course, is a prime factor. 17 is a prime factor. 31, 29 are prime factors. And 11 is also a prime factor. So I think 7, right? See, 11 squared whole power 10 is 11 power 20. So 1, 2, 3, 4, 5, 6, 7. 7 is the answer. 7 is the answer. Right? Because the word different was given. If the word different is not used, if he simply says total number of prime factors, then you'll have to express this as 2 power 17, 2 power 17, 3 power 17, 2 power 31, 13 power 31, 17 power 5 as it is, 31 power 11, 29 power 11, and 11 power 20. And then add up all the powers to get the total number of prime factors. But since he says unique, we can just count the unique bases. So option 1, 7 is the answer. Here's the next question. Try it out quickly. What is a digit in the units place of 2 power 51? That's a sitter. What's the digit in the units place of 2 power 51? You have only 10 seconds for this. Quick. I think all those who got 6 as the answer for the previous question considered 899 as a prime number itself, right? But 899 is not a prime number. Done? That's a sitter. What is the digit in the unit place of 2 power 51? See, cyclicity of 2. 2 power 1 is equal to 2. 2 squared is equal to 4. 2 cube is equal to 8. 2 power 4 is equal to 16. 2 power 5 equals to 32. 2 power 6 equals to 64. 2 power 7 equals to 128. 2 power 8 equals to 256, and so on. So going by the concept of cyclicity, you know that if you see unit places 2, 4, 8, 6, again 2, 4, 8, 6, and it will repeat itself. So I can say that after every 4 powers, the unit place repeats. So cyclicity, the cycle at which the unit places are repeating here is 4. Now you know the technique, right? What do? The given power is 51. Divide 51 by the cycle 4. 51 comes from the power, 4 comes from the cycle. What is the remainder? 51 divided by 4. 51 divided by 4, the remainder will be 3, because 48 is divisible by 4, remainder is 3. Now since it is 3, consider 2 power 3. 2 power 3 ends in what? 8. So this 2 power 51 will also end with 8. It will be some 100 digit number, but it will end with 8. That's the process. I mean, we have learned it multiple times. Yeah. Should we take up the next one? So let me present the next question. I think last 2 questions and then we'll close it. I'm sure all of you have got the knack of it, and it's all about looking at it differently so that you can find out what the answer is, and try and use elimination method. See, you may not know what exactly is the answer, but you should definitely be able to say these 3 are not the answers, and then you're sorted, right? So 1 or 2 more questions and then we will wind it up. The next question is on your screens here. What least number would be subtracted from 427398 so that the remaining number is divisible by 15? Quick. All right, time is up. Let's take this now. I'm sure it's not a very complex one. Let me present this. So what least number would be subtracted from 427398 so that the remaining number is divisible by 15? So basically it says what is the smallest number that we should subtract from 427938? 427398 so that the remaining number, after subtracting x you will get some number, right? This number is divisible by 15. This should be divisible by 15. So from 427398 you subtract something so that it is divisible by 15. Go by options, don't worry. You know the divisibility rule for 15, right? I mean, if you have to go by the regular process, you should know the divisibility rule for 15, right? What is the divisibility rule for 15? 15, the number should be divisible by 3 and 5. A number is divisible by 15 if and only if it is divisible by both 3 as well as 5. Now, first of all, so first let's check it for 5. Basically the idea is, how do you check it for 5? See, it's simple. You know that for a number to be divisible by 15, it should be divisible by 5. And a number is divisible by 5 if and only if it ends in 5 or 0. Yes or no? Only when a number ends in 5 or it ends in 0, it is divisible by 5. Yeah. Now, suppose you subtract 13. See, I'm going by options. The only way is to go by options. Simple is to go by options, right? Least number to be subtracted from that. Or you have to consider all the multiples of 15 and then come as close as possible to 427398 to check what the number is. But just go by options. So when you subtract 13, suppose you subtract 13, 427398, subtract 13. What do we get? We'll get 427385. When you subtract 3, we'll get 427395. When you subtract 16, we'll get 427382. When you subtract 11, we'll get 427387. Are you able to follow? I have subtracted these values because the question says when subtracted from the given number 427398, it should result in a number which is divisible by 15. Now when you subtract these values, these are the numbers that I get. When a number is ending in 2, is it divisible by 5? No, because for a number to be divisible by 5, it should be divisible by both 5 and 0. This number ends in 2. Is it divisible by 5? No. If it is not divisible by 5, is it divisible by 15? No. So C is eliminated. Similarly, this number ends in 7. Is it divisible by 5? No. If it is not divisible by 5, is it divisible by 15? No. D is also eliminated. The only options are option A and option B. Now, here you have to apply the divisibility rule for 3. What is the divisibility rule for 3? Sum of the digits. A number is divisible by 3 if the sum of its digits is divisible by 3. Check the sum of the digits. 4, 2 is fine, 6, 3 is fine, 7, 8, 15 is fine. This is not divisible by 3. This is eliminated. Why? It cannot be divided by 3. This number is not divisible by 3 because 4 plus 2 is 6 plus 7 13 plus 3 16 plus 8 24 plus 5 29. Is 29 divisible by 3? No. This number is not divisible. Hence option B has to be the answer. I can check. 4 plus 2 6 plus 7 13 plus 3 16 plus 9 25 plus 5 30. Is 30 divisible by 3? Yes. If 30 is divisible by 3, is this number divisible by 15? Yes. Because this number is divisible by both 5 as well as 3. Hence option B is the answer. So I should subtract 3, option B. I should subtract 3 to get the answer. If I subtract 13, I will not get the answer. If I subtract 13, I will get a number which is not divisible by 15. Which is not divisible by 15. But this number definitely is divisible by 15. So option B is the answer. So divisibility rules are important. I mean, when you come across such questions in your exam, if you know the divisibility rules for, one, I mean, of course, 1 has got no rule. I mean, every number is divisible by 1, but 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then you should know how to check the divisibility for 12, 14, composite numbers. You have to go by the concept of co-primes, right? I have explained that in the videos. You can just go through that. All right. Anyways, the answer here is option B. Let me present the next question to you all. The next two questions are like on the whole idea of division. So let's quickly solve those two questions and wind it up. Here's the next one. Quick. A number when divided by the sum of 555 and 445 gives 2 times their difference as quotient and 30 as remainder. What is the number? Option 1 is the answer. Good. Chandrahas has got the answer. Let me explain this now. A number when divided by the sum of 555 and 445 gives 2 times their difference as quotient and 30 as remainder. What is the number? So basically there's a number. Let's assume the number is n. This number is divided by what? Is divided by the sum of 555 and 445. It gives 2 times their difference as the quotient and 30 as the remainder. What is the number? Simple. What is the divisor? Divisor here is the sum of 555 and 445. 555 plus 445. So I think that's 990 plus 10,000. Remainder directly is given to us. What is the remainder? Remainder is 30, right? 30 is the remainder. What is the quotient? Right? What is the quotient here? Quotient is equal to, you understand? What's the quotient? Quotient is the 2 times their difference. Quotient is equal to 2 times of the difference. Difference of what? 555 and 445. So difference of this is 110 and twice of that. 2 times he said, right? 2 times of their difference as quotient. So 110 into 2, 220. What's the number? See, n, like n will be nothing but divisor into quotient plus remainder. I mean, that's the division, right? I mean, n is nothing but the dividend here. Right? So n will be equal to divisor into quotient plus remainder. So 220 into 1000 is 2,20,000 plus 30, 2,20,000, 30. Option 1. All these are useless, no, not even in the range. Option 1 is the answer. And you cannot be going wrong in such a simple question. I mean, this is a very, very simple and straightforward question. I don't know how come you guys have got 1250 and other answers there. Yeah? Nilab, what did you do to get 1250? Okay, next question. Here's the next one. Try this one now. When a number is divided by a divisor, it is seen that the divisor is 4 times the quotient, which is equal to double the remainder. If the remainder is 80, then the value of x is. Now this time again you have to use the same concept. Find out the answer. Quick. 6480. Alright. Look at this. When a number is divided by a divisor, it is seen that the divisor is 4 times the quotient, which is double the remainder. If the remainder is 80, then the value of x is. So basically x here is nothing but the number, I guess, right? When a number here is x, right? So when x is divided by a divisor, it is seen that the divisor is 4 times the quotient, which is equal to double the remainder. If the remainder is 80, then the value of x is. Now you know that the number usually, whatever that number be, is equal to divisor multiplied by quotient plus remainder. That's what we have to do here, right? Now we have been given that remainder is equal to 80. Look at the equation given there. Divisor is equal to 4 times the quotient is equal to double the remainder, 2 times of the remainder. Now substitute remainder equals to 80 here. You're able to follow. So divisor is equal to 2 into 80, 160. Yeah. Now I also know that 4 times the quotient is 160. So implies the quotient is 160 by 4, which is equal to 40. Done. So you know the remainder, you know the divisor, and you know the quotient. Substitute. So that number x will be equal to what? Divisor into quotient. So 160 into quotient is 40 plus the remainder is 80. Right? Now 16 into 4 is 64, 64 into 100, 6400 plus 80, 6480. Option 1 is the answer. Right? Other techniques can also be applied, but the only thing that we know in the question here, I mean, I don't think can be applied. Other techniques can be applied because the only data given in the question is remainder is 80. With the remainder being 80, I cannot do anything with the options. I can only subtract 80 from the options and find out what is the the dividend there. But that will not help. I mean, not the dividend. I will be able to get what is the product of divisor and quotient. Right, so I think simple 2 steps. You don't have to write this step and all these things, right? It's all about understanding this equation here, substituting the value of remainder to get the quotient and get the divisor, and then find out the answer. So option 1, 6480. Yeah, all of you got the right answer, 6480. Chalo, one last question and then we will wind it up. And this definitely is the last one. I'm not going to take up anything after this. In fact, I don't have any questions after this. So the last question, something different and interesting on your screens now. 49 power 15 minus 1 is exactly divisible by what? 49 power 15 minus 1 is exactly divisible by what? 8. 8 is the answer. Option D, 8. Many of you have got 8. Should we take it up? Okay. So shall we solve this now? Chalo, let's look at this. Here's the question. 49 power 15 minus 1 is exactly divisible by what? 49 power 15 minus 1 is exactly divisible by what? Options are 50, 51, 29 and 8. Right? So this is 49 power 15 minus 1 is divisible by what? Is exactly divisible by what? Which means the remainder should be 0. Right? Now how do you simplify this? See, if you go by the polynomial expansion of x power n minus 1, x power n minus 1. X power n minus 1 is nothing but x power n minus 1 power n, right? Or it is as good as x power n minus 1. How do you expand this? This can be taken as, I mean, this is one thing that you have to remember. I mean, you should know how to express a polynomial here, right? Of in the degree n. So x power n minus 1 can be taken as x minus 1 multiplied by x power of n minus 1 plus x power of n minus 2 plus x power of n minus 3, so on till x power of n minus n minus of n minus 1, which is x power 1. Finally, x power of n minus n, which is x power 0, which is equal to 1. So this is the expansion that you must know. You should know basically how to expand x power n minus 1. I mean 1 power n is nothing but 1. So basically x power n minus 1, x minus 1 and so on. So if I have to consider 49 power 15 minus 1 in this form, right, in the same format, how can this be expanded? 49 minus 1 multiplied by 49 power 15 minus 1 is 14 plus 49 power 13 plus 49 power 12 and so on up to 1, right? But anyway, I know that the number 49 power 15 minus 1 can be expressed as this. Now this 49 minus 1 is nothing but 48, right? So this is actually 48 multiplied by whatever, 49 power 14 and so on up to 1. Now basically 49 power 15 minus 1 is exactly divisible by what? I know that 49 power 15 minus 1 is equal to 48 into something. 48. Is 48 divisible by 50? No. Is it divisible by 51? No. Is it divisible by 29? No. Is 48 divisible by 8? Yes. 48 is divisible by 8. If 48 is divisible by 8, I can say the whole number here is divisible by 8. So option D is the answer. You getting it? Option D is the answer, right? Option D is the answer. Now let me also give you a smart method. Smart method is, I mean, it's not really a smart method, but a technique, a shortcut, so to say, right? A shortcut, which I'm sure all of you would love to know. I don't know how useful is it in the exam or not. I mean, you have to recall the right shortcut at the right time. So that's why you always have a challenge in, suggesting shortcuts. But let me just tell this to you. Remember, if x power n minus 1 is always divisible by x plus 1 if n is even. Now you have to remember this point, very very important. What is the point? X power n minus 1 is always divisible by x plus 1. X plus 1, remember x plus 1 if n is even. Now here you might say that, okay, so if you look at the given number 49 power 15 minus 1, can I say it is divisible by x plus 1, 49 plus 1, 50? No. Why no? Because n is not even. Here n is equal to 15. Here n is equal to 15. N is odd. Now you might be wondering, when n is odd, why are you even giving this formula? Because n is odd, so I cannot apply this formula. But then understand, 49 power 15 minus 1 can be expressed as 7 square whole power 15 minus 1, because 49 is 7 square, and this can further be taken as a power m whole power n is a power m into n, so 7 power 30 minus 1. Now if you observe, x power n minus 1 and 7 power 30 minus 1 are in the same format. In fact, 49 power 15 minus 1 also was in the same format, but this time n has become even. N is equal to 30, it is even, right? Condition is satisfied. The power being even, condition is satisfied. So this is divisible by what? Divisible by 7 plus 1. What is 7 plus 1? 8. And that is why option D, 8 is the answer. So that one point you have to remember, right? A shortcut. The shortcut, x power n minus 1 is always divisible by x plus 1 if and only if n is even. So since n is even here, after expressing 49 power 15 as 7 power 30, you can use the formula, right? So 8 is the answer. Option D, 8 is the answer. I hope all of you have understood that. Venkat Reddy says expanded using a plus b into a minus b. I don't know how do you express 49 power 15 minus 1 as a plus b into a minus b. It's not a plus b into a minus b, right? For you to use a plus b into a minus b, it should be in the form of a square minus b square. It's not a square minus b square. It is 49 power 15 minus 1 power 15, or 7 power 30 minus 1 power 30. It's not a square minus b square, right? Yeah. Of course, you can say 7 power 30 minus 1 is 7 power 15 whole square minus 1 power 15 whole square. So that will be like 7 power 15 plus 1 into 7 power 15 minus 1. But then what do you do after that? After that, you cannot do anything. Yeah. Shrikant says shortcut is the best. Yes, shortcut is the best if and only if you know where to use it, when to use it, how to use it, and all this is possible only when you are able to recall it, you know. And usually what happens is when we are taking a competitive exam, we're already under pressure, right? And this stops functioning properly, right? I mean, you will not be able to recall the right idea at the right time. This is a simple one, you can remember, but yeah. Also know the expansion. Like, you should not say that I don't know the expansion. I mean, you should learn what the expansion is. Okay. So on that note, I will close this session here. I hope all of you have had a great time joining this session. Thank you so much for joining us in this session. And the only advice I have for all of you now is to cut your preparation. Your exam is starting from 17th of Feb, so you only have 3 or 4 days left. Just maybe take 1 or 2 mock papers every day. And keep yourselves composed, keep yourselves calm, relaxed, right? Be cool so that you can give your best in your examination. All right. I see one question here from Chandrahas. He says, is Titanium program available exclusive for SSC? Well, Titanium program is not for bank exams or for SSC exams. It has been designed in such a way that it will help you get ready for more than 20 exams. Bank, SSC and other government exams, insurance and railways and other stuff, right? If you want to know the details, you can visit talentsprint.com/titanium, which is the short URL, Titanium, I mean TITANIUM, right? talentsprint.com/titanium, or check your emails and SMS. We have already sent you the link. So explore that, and if you are interested, yes, you can upgrade to it. You will get exclusive sessions on all the topics, plus one-on-one mentoring with a lot of other features. All right. Thank you once again. All the best for your Tier 2 examination, which is going to start soon. Not really keep practicing, I would say, because only a few days left, but yeah, keep yourselves cool, composed, and give your best shot in the examination.